Welcome everybody. Today we're starting chapter 7, and chapter 7 has to do with solving linear systems. Now, what a linear system is, it consists of two or more linear equations. So if we had like y equals 2x plus 3 and y equals 4x minus 2, that would be a system of linear equations because we have two of them. Now, a solution of a system of equations is an ordered pair that satisfies each equation. So if the ordered pair 8, -3 satisfied each of these equations, then this would be the solution to both of them, this ordered pair 8, -3. Now, one way to find the solution of a linear system is by graphing. The solution would be the intersection of the lines. So if we take a look at this first one, we need to tell whether the ordered pair is a solution of the linear system. Now, this will be either a yes or no answer. How we figure it out is to see if this ordered pair, 5, 2, satisfies both of our equations. So we know that the 5 is the x. We know that the 2 is the y. So if we start off with 2, and then instead of x we have 5, minus 3, instead of y we have 2, that equals 4. We need to see if this works to equal 4. So 2 times 5 is 10, minus 3 times 2, which is 6, 10 minus 6 equals 4. So we know the first one works. Now we gotta try the second one. So again, we have 2 times 5 plus 8 times 2 equals 11. 2 times 5, that gives us 10, plus 8 times 2, which is 16. 10 plus 16 gives us 26, not 11. So this one is no. 5, 2 is not a solution of both of these equations. So it is not a solution of the linear system. Here again we have our x, which is -3, and our y, which is 1. So here we have a -3 plus y is 1 equals -2. Well, -3 plus 1, that is -2, and -2 does equal 2. So this one works. Let's try this one now. So we have -3 plus 5 times 1 equals 2. Well, 5 times 1 is 5, plus -3, that equals 2. So this one also works. -3, 1 is a solution to our system of equations. Here we need to check our intersection point. So we're going to use the graph to solve the system, then check our solution algebraically. So if we look at our graph, we see that we have an intersection right here. Now that is at the point 1, 2, 3, up 2. So we see that this point is 3, 2. Now to solve it algebraically, we need to put this into our equations to see if that works. So let's see. 3 is our x, 2 is our y. So if we put 3 in for x plus 2 times 2 equals 7. 2 times 2 gives us 4. 3 plus 4 equals 7. So we know this one works. our second one, we have 3 times 3 minus 2 times 2 equals 5. 3 times 3 equals 9, minus 2 times 2, which is 4. 9 minus 4 equals 5, so this one also works. So we know that this is the correct ordered pair. This is the solution to our system of equations. Now, if we're going to graph this, we have 3x plus y equals 7. Now we know whenever we're graphing, we want it in slope-intercept form, which is y equals mx plus b. So I'm subtracting the 3x to bring that over here. Now we get y equals a negative 3x plus 7. So then we have m, which is negative 3, and b, which is 7. So on my graph, I'm going to go over to 7. So up 1, 2, 3, 4, 5, 6, 7. And down negative 3 and over 1. Down negative 1, 2, 3, over 1. 1, 2, 3, over 1. And we could just keep going until we have enough points to make our line. Now we have to do the same thing for the second one. We have to move our 2x over, so we're going to add 2x. So we get y equals 2x minus 8. So our m is 2, our b is negative 8. So negative 1, 2, 3, 4, 5, 6, 7, 8. We're going to go up 2 and over 1. So up 2 over 1. And then we make a line. Now the solution to this system is right where they cross. So our intersection looks right here. So that is over 1, 2, 3. And down 1, 2, so negative 2. So 3, negative 2 is our solution to this system of equations. Here again, we need to get y by itself, so we're going to add 3x. So we have y equals 3x. Now we don't have to put plus 0 because we already know that that's just 0, but we could, which gives our m as a 3, or 3 over 1, and our b a 0. So we begin at 0. We go up 1, 2, 3, and over 1. So we can create our line then from that. Now we got to do the same thing for the next equation. Here we're going to move the 14 by adding the 14x. So we get 2y equals 14x minus 8. Now divide by 2 to get the y by itself. and we get y equals 7x minus 4, which makes our m 7, or 7 over 1, and our b negative 4. So we're going to begin at negative 4. Negative 1, 2, 3, 4. Now our m tells us to go up 7 and over 1. So up 1, 2, 3, 4, 5, 6, 7, and over 1. 1, 2, 3, 4, 5, 6, 7, and over 1. So if I create a line from those, it looks like we have an intersection right here, and that point is 1, 3. So our solution to this system is 1, 3. Alright, I want you to try this one on your own. Solve or graph the two equations. Make sure you solve for y first, and then find your intersection. Alright, this one says, a business rents inline skates and bicycles. During one day, the business has a total of 25 rentals and collects $450 for the rentals. Find the number of pairs of skates rented and the number of bicycles rented. Well, we know that the business has a total of 25 rentals in one day. So the total is 25. And we could say our rentals could be X for skates and Y for bikes. If we add both of those together, the total would be 25. So this is our first equation. We could solve this for y by getting rid of x. So we have y equals negative x plus 25. That means our m here is negative 1 and our b is 25. Now to solve a system, we need another equation. Over here we know that inline skates are $15 per day and bicycles are $30 per day. We know that they totaled $450. So if they totaled $450, we said X was skates, so $15 times every skate that they sold or rented, which is X, plus 30 Y, which is $30 times every rental that they made for bicycles. So then we have to solve this. So get 15 over to the other side. We get 30y equals negative 15x plus 450. Now I'm going to divide by 30. And we get y equals negative 1/2 x plus 15, because 30 times 15 gives us 450. So our m here is negative 1/2, and our b is 15. So we know on our y-axis we need to have the numbers 15 and 25. So I can't go up by 1s to get to 15 and 25, so I'm going to go up by 5. So 5, 10, 15, 20, 25, 30, 35, and so on. Now, if I went up by 5s here, I might as well go up by 5s here. So 5, 10, 15, 20, 25, 30, and 35. Our first line, we know that our B is at 25, so I'm going to put a point there. Now, if I'm going down -1, that's like saying -1 over 1, but I'm going down by 5s. I could go down -5 over 5, because that's the same as going down -1. So if I go down -5 over 5, down 5 to 20, over 5 to 5, and I can keep going down like that. Our second line has a B of 15. They have an M of -1 over 2, which is actually just going down by -5 over 10. That's the same thing as -1/2. So -5 down over 1, 2, 10. 5 down over 10. 5 down over 10. That line goes to 30, and it looks like we have an intersection. Now this intersection tells us the number of pairs and skates rented. So it says that X is on 20. So we said X was the skates, and B was on 5, or not B, Y was on 5. 5 means bikes. So in this day, they rented out 20 skates and 5 bikes. Alright, here it says the Parks and Recreation Department in your town offers a season pass for $90. As a season pass holder, you pay $4 per session to use the town's tennis courts. Without the season pass, you pay $13 per session to use the town's tennis courts. Which system of equations can be used to find the number X of sessions of tennis, after which the total cost Y with a season pass, including the cost of the pass, is the same as the total of the cost without a season pass? So we know that if you get a season pass, you have to pay $90. So we need to look for anything that has a 90 in it. So we can't do A right away because it doesn't have a 90. If you're a season pass holder, you pay $4 per session to use the town's tennis courts. Now that $4 is in addition to the $90 you already paid. So we're looking for 90 plus 4x. So that eliminates B, because that doesn't have a 90 plus 4x. It's either C or D. Without the season pass, you pay $13 per session to use the tennis courts. So if you don't get a pass, you don't have to pay $90. So we're looking for 13x, the number of sessions, without the $90. This one has 13x plus 90, but we know it can't be that, so we know it has to be C.